Hey everyone, welcome back to the HFSS video series. And so far we have seen quite a bit about HFSS and how we go about designing simple Microstrip Patch Antennas. In the last one we dealt with Optimetrics, right, where we adjusted the substrate height and we saw how exactly that would affect the resonating frequency of the antenna, and we basically had the sweep results. Now we're going to do the same thing, but now we are going to introduce ourselves to MIMO, how we're going to set MIMO up. And the first thing that should come to your mind is that when you do MIMO, the rule book says that the separation between the two patches that is going to come up should be 0.5 lambda, right? So when you say 2.4 gigahertz is your resonating frequency, that means you would have to calculate its wavelength, right? So the simple formula always remains, right? You will have to go ahead and say, if your frequency is there, f is equal to c by lambda, right? In that case, you will have to calculate the wavelength, and there are a bunch of tools online, but if you want to go ahead with the manual way, that is also open. Now in our case, we want to have the frequency at 2.4 gigahertz. So the calculated wavelength in millimeters is around 124.9. In centimeters, that would be close to 12.5 centimeters. Now why is that important is because this value of 12.49 centimeters, or in terms of millimeters 124.9, so roughly 125 millimeters, this is your lambda. We want to have the half of it, so 125 by 2 should give you a value around, let's say, 62 or 63, I assume, right? So 125, yeah, should be around 62.5ish. That is basically the separation that should be there between the two patches, so that the isolation is the least. Now what is this isolation? Of course you'll have to read something or the other up, but it's basically, because of a certain radiating patch, how much is it affecting the other one, right? We want to have good isolation, so that both of these guys are able to function properly. They are able to give us the right um, kind of results that we're looking for. And there are a lot of different parameters, or rather a lot of theory that would be involved in terms of MIMO, which I would want you to read up on. The best place to look up at these would be on research papers, and I think that's the best place where you could learn a lot more, and probably just shove the research paper into some AI and get to know what is exactly going on there, because that is the best approach that we have now. We have AI in our age, right? So let's get started. Now we want to have another patch, right? That's the first thing that you would notice. How do you go about with it? The first thing would be to increase the substrate, right, in this direction, the right side, right? That is going to be positive y. If you notice, we have to go towards positive y. So I'm just going to open up the substrate, and if I just make it 100, just for example, I just want to see what happens, right? If you notice, this has gone to the right. What I will do is I'm going to select 120 for now, okay, and or rather let's say 140 for now, just for the sake of it. And this gives me enough space to work with another patch. But if you notice, the ground hasn't moved. So we need to do something with the ground as well as substrate so that these guys move together. And if it's possible, let me just get rid of the radiating hide and active view. All right, so it's there, but it's not visible anymore. So what we want to do is we want to have the ground and the substrate moving together at all times, right? Similarly, we want to have the port and the patch moving at the same time. When I say move, you'll understand when we introduce the second patch. Okay, so now what we'll do is we'll first fix the issue of ground and substrate. So for that, the best possible way is to bring in a variable. So I will bring in subs or sub y. Okay, and it seems correct. millimeters, 140, hit OK, apply. Now I'm going to go to ground. I'm going to go to create rectangle, and the Y will be replaced with sub Y because I need it to be the same as my substrate. Now, if you notice, the moment we did that, it has automatically changed to, the full substrate. Now, whatever I do now, of course, you would have had this question. Now, what do we do? How do we change the value of the variable that we created? So you have to come to project up top and project variables. This is where you would see your variables that you've created. Now, so far we did sub h in the last video where we, moved the value of this variable and we saw what it would do. Now, in this case, we don't need it. So we're just going to let it be as it is. We're going to come to this guy. So if I change it and I make it what it was earlier, 80, and this will come up every time. If you notice, ground as well as substrate are now moving together. This is one of the biggest wins that we have, because if these two are moving together, that means with one variable, I'm taking care of two things, the substrate as well as the ground. It's a big deal. Trust me, when it's going to be synchronized and we're going to be dealing with, more variables as we go on, having a single variable take care of multiple things is a big win in our books. All right. So with that being said, I think we can go ahead and now have more conversations on bringing in the next variable. So I'm just going to add 140 is what I'm going for. It's not a hard and fast rule. I'm just like going about thinking how exactly I'm going to fit that next variable in. Now, when we are going to introduce another patch, it's going to be the same as this, right? So might as well copy this. Now, a simple Control C, Control V is good. I mean, it serves the purpose, but HFSS is there to give us the right tools. So what all do we need to move? The first question is like, what all do we need? Right, the first thing that we need is this patch itself. And we also need the port. So what I'll do is I'll just select the patch and the port. And now up top, you're going to notice this along line, duplicate along line. So I'm going to click on that. And now what you have to do is first click on what you want to move and to where. In my case, I'll just move it anywhere I want. Okay, and you're going to get this duplicate along line. Total number, just make it 2. If you want 3, then fine, go with 3, 4, 5, whatever be your case. 2 it is in my case. Okay. Now, what has happened is that the duplicate part has gone somewhere else. So what you need to do is you need to click on this and you only need to worry about the y-axis. So 0, comma, we are moving towards positive y. So I'm just going to click, rather type in 35, 0. Hit apply and hit OK. Similarly, we need the same exact value. So 35, not 350, 35 and apply. We do that, and if you notice, these guys are now on the same line how it has to be. So again, this brings me to another variable, right? Now this I'm going to convert and I'm going to call it move, because I'm going to move this patch. Okay, so move variable will be currently sitting at, let's say, 40, and we need it at mm. So I'm going to type mm here and I'm going to hit OK and hit apply. So if you notice, the port has moved to 40. We need to do the same thing with the feed, which is basically the patch itself. So I'll come here and I'll just put in the variable $move. Now what is going to happen is, if you come to project variables again, and if you move this 45 now, notice what happens. Both of these guys are now moving together. That means it's a big win again. Two things are moving with the same variable, right? Now we also need to, take an account of one more thing, which is what exactly is the separation here. I would like to have similar separation on this side as well. So what I'll do is I'll just add a line from this to, if I can get a straight line, that would be great. But it's somewhere around 21 mm. That is the separation. So I would want to have 21 mm on this side. So what is it sitting at currently? Let's see. As straight as I can get it to 36. So 36 is it 36 exactly, or is it like little less? It should be a little more. Something around 36, right? So what I'll do is I'll try my best to sort of have a uniform setup. So what I'll do is project variables. So it's sitting at 36. 36 minus 21. So around 15 I need to reduce. So I'll make it 125, hit apply. Is it looking uniform? I mean, at the end of the day, we are going to be looking at, you know, we want to have the separation and we need to ensure that we're maintaining uniformity as much as possible, of course. So what we understand from this is that we have now two variables. We have substrate y, which is this, the block, the ground, and the substrate moving along the y axis. And we have move, which is now going to move your second patch to the right. Right? So now we need to set up a sweep such that we need to increase substrate and move together. They need to be in sync. This is something that is not covered in the last one because we did not have something called sync because it was only one variable. So now let's set this up. Optimetrics, add parametric sweep, add the different variables. Now we are not dealing with sub h, we are dealing with y. Starting value was 125, right? So I'm going to hit 125 first, and I'm going to go all the way to, let's say, 150 with a step size of 1 mm. Add that in. Next up, move. Move is sitting at 45 at the moment. I'll start with 45. And because I'm increasing by 25, I'm going to do the same thing here. That would end up 50-70, right? With a step size of 1. Hit add. Right, so now if you leave it here, what is going to happen is it's going to take combinations of all these values, right? And this is going to have 676 different combinations, which we do not want. So click, hold control, click on the other variable and sync these two up. These will only sync when both of them have the same exact amount of steps. So if your step size is varying, but let's say, for example, if it was going from 125 to 175, or let's say anything else going by 2.5 or something else, and they somehow end up being the same amount of steps, then it makes sense to go for this sync part. Otherwise, you won't be able to sync this. You would get an error. And if you want to see that, I'll just make this 60, for example, hit update, hit OK. You would get this instantly. Right, so it won't allow you to change unless you unsync them. Now you are able to change at the cost of more operations. Okay, just keep this in mind because sometimes you end up running the sweep and you have not synced them. Good luck to your PC and you, because first of all, this is one of the most time consuming steps, but at the end of this you are able to do analysis of all sorts, wherein you will actually understand what variable is playing a role, what exactly is the right approach, wrong approach, this, that, everything. Okay, so far we're done with syncing up. This is a very important step. Now what I would also recommend you to do is, when we did the copy part wherein we duplicated along the line, I would suggest you to bring it to the starting point of your sweep, because these are the values that you actually get to see nominal value and that kind of approach. And as you deal with more and more variables, you sort of tend to lose track of your values, and that is not something that I would want you to go through. So best case is bring it to a starting point which you feel is like, okay, this is where I wanted to start, and then go ahead from it. Now we've basically dealt with the Optimetrics part. We need to still deal with the results, because now I don't want to deal with VSWR. I don't want to deal with this 3D plot. I want to deal with S parameters and gain. Okay, and now there will be more things coming in. So modify report, the moment you do that, we'll notice there are more quantities or whatever this is. Now we will take in all three of them. That is S11, that is going to show us the S parameters, the return loss on the first patch. S22 will be the return loss on the second patch. S12 is basically the isolation. And on most occasions, what we usually say is that S12 and S21 are basically the same, or they have the same value. That again is something that I've seen across a lot of different books. So I'm going to follow that. You can take either of them. I'm going to hit new report. Okay, so that means I have now, I can get rid of this. This is now going to give me the S11, S12, and S21. But again, we need to go ahead and click on families, come to use all values, use all values. Otherwise, you're going to end up having just one single case. Same thing with gain. You have to come here, families, use all values, use all values. And so far, because I've not made any changes, it's still at a max of dB gain total. Okay, two things done. Now, what is left is, of course, you need to start running with the sweep, but you also need to notice that the second patch has not been given perfect E. So just go ahead and do that. A lot of occasions this has happened where you end up not giving it perfect E, so the second one is just existing, it's not acting like an antenna. And another step that you need to keep in mind, as far as I know, now this is something that I've learned the hard way, wherein you need to come to HFSS, come to fields and edit sources. For MIMO, just ensure that this is 1 and 0 or 1 and 0 the other way. Okay, one of your ports has to be 1, the other one has to be 0. If both, that basically means that one of them is being powered, the other one isn't. And MIMO is basically that. Multiple in, multiple out, right? One has to receive, the other one has to transmit. And if you have both of them transmitting, I don't know how exactly HFSS takes it as, but I would recommend, and from a lot of reading that I have done, I would recommend it to be 1 and 0. If you have a 4-port setup, have 2 ports firing, that is transmitting, and 2 ports in receiving, so 0 in that case. I'm going to hit apply. And just to ensure that our radiating surface has also adapted, yes, it has. It will adapt automatically, so we don't have to worry about that either. Port 1, so you can see port is being selected. This is the first patch, this is the second one, and the ground is underneath. So now we are ready to run this parametric sweep. Okay, so let's just go ahead and hit analyze. Let's wait for this to complete. And then once we are done with this, we'll get back to the results, what it has shown us, whether or not there were improvements, whether we need to do something. Let's find out after the sweep. Well, a quick note, what you would notice is that only S11 is being reflected here. So I'll just go ahead and reselect these guys, apply trace, so that all the other values are able to be seen. So the different colors would be showing you different values, and also I will add back -10 here just to see what happens, right? So in our case, so far there is no improvement in bandwidth, and I hope that there is some improvement in gain, which so far you can sort of see a climb, but we will wait for the results to come in. Once they are in, then we can deal with it separately. But for now, we're gonna let this run. We're looking for S12 to be below -15, like in this case. It's almost there, right? It's moving away. That is what is the expected outcome. Your S12 or S21 should be less than -15 dB. only then it is considered to be a good isolated system. So until that happens, we're going to let this sweep run. There are only 22 steps left. So let this run and let's see what happens. Well, with that, we are done with the sweep. And yeah, you will notice that there are a lot of values now to the right. But what we need to concentrate on for now would be any values that are less than -15. So what I do is quickly add a Y marker and -15. Right. So now if you notice, these are values along x-axis that are definitely, below. Like you can see this gray line now, 49, 129. These are now going to be your important variables, because from here on, you can basically tell that, at these points, the isolation is the least, or rather a good isolation has been achieved, and the interference, or there's another term that I'm forgetting at the moment, is the least. Now over here on the other hand, if you notice, the bandwidth has not really increased much, but let's check out the gain. The gain, okay, from where it was, it has ended up to be around 3.67. So again, not the best of gains, but uh, we can definitely continue with, with the parametric sweep. Now all we have to do is, we stopped at 150, so we'll keep 150 as our starting value, go up till, let's say, 175, update that, stopped at 70. Now this time I'm going up another 5, so 95, hit that, update, and again you will have another 26 to go through. So this is basically going to give you an idea of whether or not your gain and your S11, whether they are indeed improving or not. In our case, there was only S12 that has, improved as we have gone on with this sweep. We would want values that are under -15 at all costs. Otherwise, there's literally no point in doing this. If you also notice, the other dips that did exist, there have been similar values that have shown up in terms of bandwidth. So there's not been a significant increase there, although we would have wanted to see that. But in this case, it hasn't really shown up. So that's okay. Let's run the next set of sweep, and then in the next video, I'll show you all what exactly were the results. And we will then proceed towards 4-port setup, wherein we'll have 4 ports, or rather 4 patches, and we'll go on from there. All right, see you there.